Hey, greetings there. I'm Nick Hancock, President and CEO of Midwest Lightning Rods. We are a lightning protection installation company right here, Local 146. We're based out of Decatur, Illinois, and we are signatory members to IBEW. How it works for us is when we go to another local, we bring a lightning protection specialist on site, and we are required to pull from the local bench of wherever we're at in order to find installers to come work with us. Being that no one sitting on the bench at the electrical union currently has any clue of how to install lightning protection, my goal in this video is to educate you. You are either someone who I've sent this video to watch because you're going to come work for me, or you're watching it as an apprentice, and I'm going to take up about half hour or so of your time here, and it's going to make it so if that time would come where you would get the call off the bench to do some lightning protection work, it will not be near as foreign to you as it would be if you did not watch this. So when a lightning strike hits a building, it's looking for its a path to ground, and we provide it with a path to ground with the least amount of resistance, or a direct path to ground, if you will. What we do to make that happen is we create a new high point of a structure. It doesn't have to be way taller, way higher. It only has to be inches higher. But what we do in that is we make sure we create a new high point of a structure with the lightning protection components installed that give lightning the most direct path to ground with the least amount of resistance. And we accomplish that by just installing according to UL 96A, LPI 175, and NFP 780. And here's how we do it. So there are two different types of lightning protection system components, and they are copper and aluminum. And according to underwriters, they are equally effective metals in regards to lightning protection installation application. They are used, sometimes they are used specifically because out of code requirement for inability to install on dissimilar metals, while other times it is for aesthetic reasons and owner preference, because copper and aluminum both fade to match better with different types of siding or fascia or whatever, what have you. And in those two types of metals, there are two classifications, which is Class 1 and Class 2. Class 1 is for any structure that is under 75 feet in height, and Class 2 is anything 75 feet tall or higher. And the difference in the two is not the installation, but just in the equipment itself. Class 2 equipment is more substantial. Just larger, heavier, larger gauge. So bigger is bigger. But so I mentioned the different types of metals because as I go through and touch on some of the components that we use kind of regularly, if you see an example that I pop on the screen, keep in mind that whether it be aluminum or copper, everything is made in both. And there is bimetal fittings that make the two be able to exist together in the same system, if you will. Air terminal units is the first thing I'd like to touch on. Air terminal is a lightning rod as you know it. An air terminal unit would be the air terminal and the base that it fastens to or screws into, and that base is what is mounted to whatever type of substrate we are mounting to, whether it be a rubber roof or a metal roof cap or a chimney flue or a chimney top or a safety rail or anything that we may mount to. there would be a specific type of base that the air terminal would go connect into, and together they would make up an air terminal unit. And then there is conductor cable. There is primary and secondary cable. We always just use primary. We don't use any of the smaller cable. However, conductor cable is fastened to whatever it is ran on or mounted to. It is fastened every 3 feet, every 36 inches. It will either be running through an air terminal base or it will be fastened with a cable fastener. Adhesive mount cable fastener if it is an adhesive mount system, and a loop fastener if it is any other application. Standing seam roofs have standing seam roof clamps that you mount to the seams themselves and mount the components on them. But for when we run down leads, whether they be off of a rooftop unit or whether they be off of a penthouse or whether they be off of a building going to ground, we use loop fasteners, and we either nail it, screw it, or glue it. And in the brick, we use the hammer drive anchors. There are numerous types of, as we get in, you'll see that we have to connect to our system to quite a bit of stuff on the rooftop, and we have various methods of doing that. There's all kinds of different, bonding lugs, bonding straps, bonding plates, and they all definitely serve their purpose. But there's variations to choose from. We have what we like to use and that we stock and we use, but there's really a lot of ways to skin a cat when it comes to just bonding something to the lightning protection system. There's also ground rods, which everybody's probably familiar with. However, our ground rod clamps are not the acorns. They are lightning protection grade ground rod clamps. If we do not CAD weld or exothermic weld to the ground, then we would be using a ground rod clamp like that you've seen. There is also through roof connectors, which is a piece of 1-inch PVC with a cap on top, and on the underside it has a lightning protection fitting, and on the top side it has a lightning protection fitting, and it gives something for the roofers to be able to boot, weather tight, and warranty the penetration. The majority of our installation that we do is adhesive mount. It didn't used to be that way, but I try to even sway architects and designers from anything other than, because the adhesive that we currently use on most jobs is M1 structural adhesive by Chemlink. It's a great product. It's withheld the test of time now for some years, and it's just a phenomenal adhesive. And the less penetrations that I'm responsible for, the better. Because I don't want to sit in roof leak meetings, and I like to go on jobs and not have even created the possibility. That's why when we do go through the roof, the roofers are contacted immediately, and they are sealed up, and then our fitting is sealed on top, so that kind of takes us out of the loop there. There's a lot of specialty equipment, of course, but overall, I think we covered most of that. Now we need to talk about what we do with it. So when it comes to the actual installation process, there are many rules of thumb to just keep in your mind to follow. There's key numbers that matter, and that's what we're going to go over here. So how we start off installation of any lightning protection system is we lay out the air terminal units, and that gives us our base of where everything else has to go or will be going. And so how we treat it is, if you get on a rooftop, regardless of if there is a bunch of rooftop equipment, whether it be air handler units or safety rail or whatever. We treat the roof as if none of that is there, and we protect the roof itself. And how we do that is, I have to reference gable roofs as well as flat roofs here. So I'll go back and forth with it, but we'll start off with, let's say, flat roof. The rule with lightning protection air terminal unit is we have to stay within 24 inches of the roof's edge on the top side. So we would be making a perimeter around a flat roof, a line all the way around it to where there will be air terminal units mounted at every outside corner and every 20 feet on the perimeter. And our spacing with where they have to be located, if we're assuming that it's not a parapet wall that you have to install on that 12 inches or 18 inches, it has to be our air terminal unit. Our air terminal has to be within 24 inches of the roof's edge at all times. So we like to stick around 18 inches just to be safe. If there is a roof parapet wall or a roof cap that we are mounting to, we usually try to stay to the inside of that, assuming it's not over 24 inches. And every 20 feet around the perimeter of a structure, there will be an air terminal unit. In between those air terminal units is where it will be fastened to the roof. The cable will be fastened to the roof. Our conductor cable will go from air terminal base to air terminal base. And every 3 foot in between the air terminals that are spaced out at 20 feet, we'll be fastening 4 or 5 times within there. So whether it's adhesive mount components or whether it's whether we're screwing or gluing, either way, every 3 foot it has to be fastened. And that is around the perimeter of the roof. So around the perimeter, every 20 feet air terminal unit, every outside corner air terminal unit, every 100 feet we will be going to ground. And we will do that with a down lead, whether it be concealed in a PVC raceway that's already installed by the electrical contractor, or whether it be we're going through the roof and bonding to the steel on the underside of the roof. Because if any metal body, and that's including structural steel, is over 3/16 of an inch, it is said to be able to carry a stroke of lightning. So we are allowed to use the structural steel as our down conductor. And to do that, we would poke through with one of the PVC stems that you've seen that I threw on the screen a little bit ago. And we go to the underside of the roof and we connect to the steel, and that is our ground point for the roof. And in order for that to take place, then we have to grab and ground the steel at the base or at grade level to complete that circuit and that system. The amount of times we go to ground is every 100 feet, but the number is every 100 feet on the roof you have to go to ground. But the quantity of grounds for a project or for a job is indicated specifically based on the footprint size of the building. So that would be the size of the building at grade level. So if it's 1,000 feet around, it takes 10 grounds. If it's 1,500 feet around, it's going to take 15 grounds. And that doesn't mean, it doesn't matter if it's a big cone to where it's 1,000 feet around and it goes up into a cone and only takes one air terminal unit. You have to come to ground based on the number of feet that is in the perimeter of the footprint of the building. That dictates it. But so the magic number so far is within 24 inches of the roof's edge, you'll be mounting an air terminal unit at every outside corner and every 20 feet with cable fasteners in between the air terminals, fastening the cable every 36 inches or every 3 feet. Then every 100 feet, we will be going to ground by means of a down lead. So when we go over the edge of a roof, and this even will applies to when we discuss rooftop equipment, air handler units, roof vents, whatnot. Anytime we go connect to something on a different level, or we're turning a corner or a bend, what we have to keep in mind, and this is very important, is we have to maintain at least a 9-inch bend radius. So what that means is you cannot bend this cable at a 90, a 45 at best. So if you keep that in mind, then that would mean that when you go over the edge of a roof, rather than being able to ride the contour of the 90, we essentially have to loop out and over. And that's code. That's what we have to do. So that has to be kept in mind during the layout process of, you don't want to put a cable fastener adhered almost to the edge of the roof on top and then go over the edge and put it right on the edge, because then it would have to bend. So you have to give some space, leave some space for proper routing, because not only will the cable not, it said that it could, the surge could jump off the cable on a 90-degree bend. So we like to not let that happen, because it's not to code, and we would just have to go back and correct it. So the other rule with the cable is it has to maintain a horizontal or downward path to ground. So what that means is, if there is just an example, if the cable is getting installed and there is a chimney, we don't go up the chimney and back down. If there's a ground on each side, what we would do is run the cable straight right around the base of the chimney, even with the roof line, and then whatever components we had on the chimney top, we would come down and connect to that horizontal path that we have. Basically what it is you can't go uphill to get to ground, and we just stick with that, and it maintains pretty simple. When it comes to a gable roof, like let's say a slate tile or asphalt shingle roof, being that there is no perimeter on the roof side, it's just peaks and ridges, you stay, the rule there with the 24 inches is you must be within 24 inches of the end of the roof. Same thing with the 20 feet spacing. Same thing with the grounds will be determined based on the footprint of the building. So whatever is most convenient to get to ground, but we have to have the proper quantity, and we can go to ground from the peak no less than every 100 feet. The 24-inch spacing, comes in kind of handy, is essentially what I always used to do is just take my hammer, and I would go bam, lay it down. It's about 18 inches long, 15 inches long, whatever. And that's where I'd put my first base, because when you run the cable through the air terminal base, which has a cable connection fitting on it, in order for you to route it to go either bend the corner of a square roof or a corner, or to go to a down lead, if you put your air terminal right on the edge and we have to maintain that 9-inch bend radius, then you're going to be looping outside over the roof and back. So if you stay 18 inches away, that gives you room to loop it, loop the cable. And that's the whole idea. Can't bend 90s. That's pretty much it with that. So on every rooftop, or at least most rooftops, there are some type of rooftop extremities. And off the top of my head, I can think of tie-off stanchions, safety rail, roof hatches, solar panels, skylights, roof vents, condenser units, cooling towers, anything that you would find on a roof, drains, anything you would find on a rooftop. So what we do with these is in the beginning, I had stated that we maintain the high point of a structure. In order to do that, the rule is for the lightning protection is our air terminal unit must be 10 inches taller than anything on the roof. So we are 10 inches tall. We are the new high point of everything on the roof by at least 10 inches. So that being said, if you install air terminal units around the perimeter and on the mid roof, and there is anything out in the middle of the roof or somewhere on the roof that sticks up over the height, let's just say 12 inches. If you're mounting on a flat roof and something sticks up over 12 inches, you have to treat it like you're putting its own lightning protection on it, because that's what we're doing. This is where a few rules come in, that some of them are just rules and you'll have to look into it, or I can explain, but you just have to stick to them, and the reasoning behind that is probably we're not going to dive into too tough. So any extremity that is as tall or not at least 10 inches shorter than our lightning protection system height, which is the tip of our air terminal units, it must have lightning protection components installed on it to protect it. So that would mean an air terminal unit or air terminal units. What decides the number of air terminals is like anything that is 24 inches by 24 inches or smaller, you can stick one air terminal unit directly in the center of it, and you can come off of it with just one lead and connect it to the nearest main conductor, main lightning protection conductor, if it's within 16 feet. So what that means is if you have a mushroom vent or a soil pipe that sticks up 18 inches and it's 10 feet away from our cable that's mounted on the roof already, then we put an air terminal unit on that, and we run a tail of cable through the cable holders that we've installed from that unit back to our main conductor, and it's considered protected. If it's further than 16 feet away from our main run, then we have to come off twice and go to our main conductor cable. Same thing for anything, regardless of the distance, if it requires more than one air terminal unit, which will be decided based on size and shape most of the time. So if you have an air handling unit that requires 4 air terminal units, you put them on each corner or outside corner or wherever they would go, and you would route them in 2 different directions coming off of that unit. A lot of times we'll route 2 different paths right back to the same main conductor, essentially make a U out to the unit and back and come off and double into it. But we have to provide it 2 paths to ground. Even if those 2 paths go back to the same path, that same path has more than one path to ground, if that makes sense. It does when I say it. So if it's within 16 feet and it only requires 1 air terminal unit, then you can just run one lead off of it back to the main conductor. If it's further than 16 feet away or it requires more than 1 air terminal unit, you have to come off twice. If for some reason what we were installing on top of the roof would be more than 200 feet around, then you'd have to come off every 100 feet, just like we do for grounds. Same deal. So this even is the case with non-conductive bodies. So there are areas where they'll put in PVC, like 2-inch or 3-inch PVC waste pipe now, and places that used to have like the iron soil pipes, and even though they are non-conductive, if they are taller than our lightning protection high point or within 10 inches, we got to put an air terminal unit on them and connect them as well. So now let's go with things that are shorter than our system, like roof drains, most soil pipes actually, some skylights. If they are within, if it is a conductive material, if it is any kind of metal, and it is within 6 foot of our main conductor, which our lightning protection conductor on the roof, if anything that is metal, regardless of height, is within 6 feet of that conductor, we have to connect it to our system, which, yeah, usually just a bonding plate or a bonding strap or something like that. So anything metal, we create a new high point on the stuff that's taller. The stuff that's lower, we bond to it to prevent from side flash from a direct strike. So every job or every project has its own, specific things that we have to do in order to accomplish what we want. So it's not really just go in and do every job the same, although the rules that we follow and the codes that we follow and everything is the same. There's just more than one way to do it. So a lot of job specific things, but what you've learned today over the last half hour or so is definitely sufficient to get you started and have you well aware of what exactly is going on when you enter the field for lightning protection. So thank you very much for your time. And maybe some of you I'll see along the way. And if not, you definitely have a little bit more insight into the lightning protection game and industry than you did when you started, I hope. If you would have any specific questions, don't hesitate on reaching out. Again, I'm at Midwest Lightning Rods. You can look us up to touch base. We're on all social media, and we're listed, so you can give us a call, talk, whatever you need for anything further. But thank you for your time. Thank you for your attention, and stay safe out there. Be blessed.